Hello, guys. Um, just wanted to talk a little bit about uh, probably neutron stars. It's a topic that is really interesting to me. I think that the how they're made, and the way they spin, and um, just how they warp time and space, is just incredibly amazing. Like they can spin and then create gravitational waves that actually bend time and space, and that's super interesting to me. They are made of just super dense material um, that a sugar cube weighs like the all of humanity. If you took every single person, man, woman, and child on Earth and condensed them down to a sugar cube, that's like the density of a neutron star. And or you could take Mount Everest, or you could take every single car and truck in the United States, and which is like 300 something million, and then condense it down to a sugar cube, and then um, you'd have the density of a neutron star. Um, and I've heard that like when creating a neutron star, one of the most fascinating facts to me is that the inside of a star is a iron core when it's about to go supernova. And this iron core is uh, gets about 1 to 2 solar masses, and then it's the when it and then it finally it can't hold itself together anymore. It can't by so gravity wins, and then it collapses down at 20% the speed of light, um, and it creates a shock wave that all the matter comes in and lands on that core, and it just boom bounces back off. And that's basically what a supernova is. And uh, the it creates so much radiation that you know, and it's just mind-boggling. The formation of a neutron star. Even more so, what makes me even more excited is magnetars, because the extreme forces with magnetars, not only is it a neutron star, but it's also um, it does has a very very strong magnetic field, and um, like billions of times the Earth. But like, if you took a regular neutron star, it'd be like 10,000 or so more than regular neutron star. It's insane, and uh, it's just amazing that some of those things can be, created and exist out there in the universe. And the 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 extreme forces that happen out there is just how, for example, you can have an entire galaxy, and then in the a supernova can actually outshine an entire galaxy. Uh, so um, I think that is quite impressive. Uh, and you know, one of the things is also interesting is like quasars, because um, so if you don't know what a quasar is an active galactic nucleus. And what I mean by that is that it's in the center is a large black hole that's actively feeding, and it shoots out um, these gamma rays that the matter goes around and around and around and collides with other matter and heats up and um, shoots out the poles of the black hole. And um, this matter, like regular protons and electrons and all that, plasma, gases, um, can will shoot out these poles at 90 up to 99% the speed of light, and that is just mind-boggling crazy, because I mean, think of the entire Earth, and then you reduce the Earth to a plasma, which anything can be reduced to a plasma with enough temperature, or gas. You know, everything has a melting point. You know, a a vapor point and stuff like that, and it can all be um, shot out at incredible speeds. And if a we discovered that if a quasar is pointed directly at you, you know, billions of light years away, um, that and it's an active galactic nucleus and it's pointed straight at you, even billions of miles away, the it can outshine the whole galaxy. And actually, if you have a star, you know, within the Milky Way, only a couple thousand light years away, is that if you take a star and then you take that active galactic nucleus right next to it, I saw a picture that the the um, the galaxy billions of light years away was the same brightness as the star, only a few thousand miles away on the telescope, like whenever they saw it. And the fact that you can see the fact that those are the two the same brightness is, I mean, if you were, I would say, even a million miles away, million light years away from that nucleus, that it would probably sterilize anything. If Earth was, you know, it would sterilize anything in its path. Um, and that's just insane, the amount of power that can be generated. And it's what I like so much about it is that it's a very emotional thing for me because it's so humbling knowing that um, I'm just like this, you know, tiny piece of this whole big thing that's going on, and not even it's just I'm like an ant compared to everything else, you know. And ants are um, it's just I don't know what to how to feel about that. It's almost hard to put into words to how you feel about um, how big this universe is that we live in. And um, I wish that we could see um, further than we already have with the James Webb Telescope, and just and see what is beyond. I don't think we'll ever be able to see what's beyond time and space because we are in a universe of time and space. So I don't think it's I mean, can't wrap your head around there being an edge to time and space. But infinity is like it can't be real because infinity is impossible. Even whenever they say that the singularity of a black hole collapses down to infinity, and I don't believe that. I don't believe anything can be infinity. Um, so um, I think there's inside of a black hole. I think there's some other type of degeneracy pressure that keeps keeps the singularity from collapsing. I don't think it's a singularity. I think it's, you know, some other form of matter that's in there that just is impossibly um, de- dense and just, I mean, just can't be collapsed anymore. Um, that's what I think. Uh, and so, I mean, there's my take on some things in space.